Since this is being recorded between class sessions, I'll go ahead and put the date between our class meetings, and I'll go ahead and put the 24th. All right. So in this problem statement, we're being asked to find the force in members C, G, and GH. So I'll take a note of what those are first, and do note symmetry with the loading of the truss as well as the design. We're being told explicitly to use method of sections. So I like to first indicate what the members I'm looking for are, and that helps me visualize where I can take my cut. I'm also going to give myself a note that if this is my positive sign convention, oops, not that, but this, yx, then I'm going to make the assumption that I have a reaction force, not solving for it yet, but that I have reaction forces that look like so. And this is a roller, not a pin. Alright, so I also have the truss drawn again below. And over here, what I will do is I will go ahead and note different observations. I will also just make some notes about the symmetry right here. So let's start with that. All right. So because the way in which the loads are being applied are symmetrical, we have in the middle two larger loads of the same amount, and at the reaction forces we have a point load both of the same amount but also less than the value inside. Using this information, we could make guesses as to what our reaction forces would look like, but we can also quickly calculate it. So right off the bat, we know that there are no horizontal reaction forces. There are no horizontal loads being applied here. Okay, so first observation we can say is AX is equal to 0, and as a reminder, there are no horizontal external loads. So anytime you can just make these quick observations, by all means do it. In previous examples, I've gone through a method of sections problem without solving for reaction forces. In this case, we can't ignore them. But thankfully, by making an observation and looking at the loading, I can basically infer that it's going to be the same on both sides, right? Because with this truss right here, you have a reaction force here and a reaction force here. Oops. And because our loading is the same on both sides, we can distribute that 50-50. So then for AY and FY, I'm going to just do this real quick. So we have two large forces here, we have two small forces here, and then we have two reaction forces here. We'll call this AY, we'll call this FY. We know that this is L over 2, L over 2. I'm using this beam to replicate just a zoomed out picture of this truss here. And we see that I can take a moment at A, solve for F, take a moment at F, solve for A. I can take one moment and use one force equilibrium equation. But it's safe for us to say that, and I'll put this here, so can take moment about A or MF. You can even sum the forces and then divide that by 2 because it's the same. Note force distribution. And so therefore, AY equals FY, which is equal to the sum of all your vertical forces divided by 2. So we can say that AY is equal to 3 over 2L, and FY is equal to 3 over 2L. And yes, both are upwards. So always make observations first. All right, let's go ahead and now take a look at this picture here. And we'll make a quick change. I'm going to, we'll keep the pin there, but I'm going to quickly also add, and it's kind of hard to, it's a little tricky to do this when you're drawing it out. I just hope it doesn't get lost. AY, and then we'll put FY, which is L over 2, 3L over 2. And then all right, so here's our picture. We have our reaction forces acting on here. And just to remind ourselves, okay, so these are the two members that we're looking for. So it said to use method of section, so that would mean we'd have to take a cut. So let me kind of just write out our steps here. 1, observations. Sometimes I call it a 0th step, sometimes I call it the first step, but you know, for us, this is our first step, observations and reactions. We're given dimensions, we're given a lot of the information that we need, and we're noting which members we're cutting through. Next is to pick and make your cut, right? So we can explore options, but we're going to pick and make, we're going to look at our different options and then cut through them. So remember, when we are dealing with method of sections, we want to cut through 3 or less members. Each member exposes a force. For one free body diagram, we have 3 unknowns we can solve for. So again, this problem is pretty nice. I can go ahead and make a cut there, and I'll call that cut 1, which cuts through CD. It cuts through CG, and it cuts through HG. And then the 2 members that we're looking for are our cut through. Great. Next thing you want to do, draw cut FBD. And of course you want to pick a side, right? So how do I phrase that? Pick a side and then draw the FBD for that. And note exposed forces. So let's go ahead and come down here, and we'll just go ahead and redraw it. And I'll take a minute or two to see how I can do this. Kind of like things to line up and have it line up close enough, if not perfectly. Okay. And what I'm going to do is this. I'm going to just erase those members, and it does not matter which side I pick here. So I'm going to go ahead and take this side real quick, and I will actually change the color and focus on the left-hand side. So of course, if you're drawing this by hand, you can just pick, like you can draw it or shade it in however you want, and then go ahead and try to remember what this looked like. So what did it look like? Okay, horizontal, horizontal, and then C down to G. horizontal, oops, horizontal, horizontal, and C down to G. And then over here, horizontal, horizontal, G up to C. All right, so we have our cut right here, and I'll go ahead and kind of just say cut 1, and this is our left-hand side, which we chose to look at. And I'm going to go ahead and label those exposed forces. And let me do this in a different color so we can, oops. You know, I'm a fan of having things kind of noted here. Let's see if I can change that up. All right, perfect. And let's just go ahead and go with this color here. Oh, and I did not copy in my picture this really important value, 3L over 2, and all right, so again, don't forget what you're looking for. I think it's those two. Correct, it is. All right. And anything else that we should take a look at before we go into solving this? Again, I might just make some observations with my cut and what the forces look like. And these are observations you don't have to write down, but for the sake of this being a demo, I will go ahead and write them out for you. And what are things that I note? So CG has X and Y components. Remember, once I drew out my sign convention, and there it is again for you. And then I also note that CD and HG are only in the X direction. So these two actually help me out because I can use this and I can go ahead and kind of, while making these observations, list out my strategy. So because CD and HG are only in the X directions, I can use a Y formula to solve for CG. All right. Some other observations here. We're not looking for CD. So if you can always rule something out, that's great. And so then let's explore line of action for that. So let me just write this out. Line of action for CD. And let's see where that goes. So I'm going to go ahead and take my tool here, and I'm going to go ahead and draw out these line of actions. I'll choose orange since that will stick out a bit with this diagram. And let's see. I'll start with CD. Maybe I ought to label these. So this is CD, this is CG, this is HG. So I have that line of action, and then not, oh dear, didn't do my best job with lining this up. So I'm going to just do that. I'll just keep it there because of the fault in my drawing. And then let's go ahead and do HG. Alrighty. So when looking at line of actions, it's always great to see where they where two forces can intersect. That's always a good point to look at. And we see that joint C is shared by CG and CD, right? So if I've already solved for CG and I just have HG to look at, then let's see. They both pass through joint C. Therefore, take my moment about C to get HG. Great. So now that I've made these observations, I can go ahead and go in with that math there. All right. Another tip, if you'd like to, you can also do this. Oops, what's happening here to my screen? Sorry about that. I would say observations and strategy for how I'm about to go into this. All right. We can also look at summing forces in the y, summing forces in the x, and a moment about a point of interest, since we have three unknowns. Since we have three unknowns, but I do like this method here because it gives me exactly what I'm looking for. Okay, so let's go with that. So let's paste that picture again. Move it over. It's probably not lined up, but that's fine. And I'm going to go ahead and make my cut. So I made my cut. And I'll just go ahead and draw it on here. I'm making the assumption that from the left-hand side, and I'll box that from the left-hand side, everything's in tension. Again, I'm making that assumption. I'm allowed to do that, and if it's incorrect, then I can change the sign or consider the value. Okay, so quickly I'm going to just note my point of interest as C there. I'm going to also just make sure that when I do look at the forces by itself that I have enough information. All right, and so remember when we are looking at one side, and this will actually work. Let's see. That's probably not dark enough. So let's do this. There we go. We're not concerned about this gray side, right? We're concerned about the side in which we took these different cuts in. So, sorry, we're looking at the left-hand side of the cut and how the forces are exposed on that side. Don't forget, we have our reaction forces, even though, as I mentioned, we're not entirely concerned about solving them. And let's see if this works. All right. And I can redo that. I know it's fun to watch me go back and forth here. Alrighty. Okay, so now let's go ahead and go with that strategy of ours. So then our last step is to solve, right? So first things first, and then so we're saying cut 1, left-hand side of cut 1. Summing my forces in the y direction, we have 3L over 2 minus L over 2 minus L, And then we also have components for this guy. So we have CG, what is that angle? Are we given that angle? Let's call that theta C and solve for that real quickly. And then we also have here, we have CG, and I guess that would be sine theta, and this would be cosine theta. Okay. Let's quickly get that angle. And I'll go ahead and just put that note here real quick. So theta C is equal to what? Tan inverse of, what are the dimensions that we're given? We're given 4 for the horizontal length, and we're given 3. We're given 3 for that vertical length. So this ends up looking like 4 over 3, which ends up being 51.13 degrees. Or sorry, 53.13 degrees. Okay. And so let's also incorporate that into our formula. Minus CG cosine of theta C. And what do we get for CG? What do we get for CG? Let's see. If we were to do the math, we get that CG is going to be equal to 3L over 2 minus L over 2 minus L all divided by cosine of theta C. And then what does this look like here? So this, if you want to factor out the L, 3 over 2 minus 1/2 minus 1, which is 0. So it turns out CG is equal to 0. CG is a zero force member. We may not have been able to infer that directly by looking at the way the truss is designed, but it turns out that CG has no, with the current loading setup, CG has no internal load. All right, so CG is equal to 0. So it's not tension or compression, it's nothing. Okay, and then let's go ahead and take our moment. And as we looked in the previous step, so coming up here, we see that at C, these two forces coincide. That would be a good point. Even if we did not know that CG was a zero force member, it's good to kind of map out these steps beforehand. Okay. So let's take a look at that one, and let's see. So I'm taking a moment about C. I'm going to first start with A and kind of go across joint C that way, or the point C that way. So what do I get? L over 2 and 3L over 2 will share the same effective length. So I'll put those together. 3L over 2 minus L over 2 multiplied by the distance from A to C. And it's that perpendicular distance. Or that, yeah, okay. And how can we determine if this is positive or negative? So 3L over 2, that is positive, that is negative. So I'm going to do this again. And I'm going to say L over 2 minus 3L over 2. Because L over 2, since that's pointing down, that will cause a counterclockwise rotation. So even if you have two forces acting on one point, be mindful of the direction when taking your moments. Okay, so we have that one there. How about this force here? This force passes through C, so there is no induced force with that one. However, we do have HG over here, and HG, that's a distance from H to C, that's 3. And what direction is HG going to cause us to rotate in? It's also going to be counterclockwise. So then plus HG D, and it's the length of that member, so I'm just going to call it HC. And then let's put a quick reminder of what's what. So this distance is going to be 3. This distance is going to be also 3. It's this distance here. And I should put not perpendicular, that's misleading. I'll put horizontal. It's the horizontal distance from A to C, and we get that that is equal to 3. And so then we're able to solve for HG. And what do we get there? We get that HG is equal to L. And we were correct about the assumption there. Let me also just make this. And if you want, I'm going to attempt to do the math real quick here. So we have L over 2 minus 3L over 2 times 3 plus HG times 3 is equal to 0. 3's are gone. So now we get L over 2 minus 3L over 2 plus HG is equal to 0. HG is equal to 3L over 2 minus L over 2. Take out the L, 3 over 2 minus, done. All right, so that's the answer to this question here. So again, similar to a lot of the other examples, you want to really practice noting observations and kind of making judgment calls. Like, is this a problem where I will have to boom, 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 follow the traditional procedure, reactions, cut, take a side, so on and so forth. And if so, go ahead and do that. And then separately, another takeaway here is sometimes you can take this whole picture, and let's do this. So we'll get a bit comedic here. And then bucket color is also, so we can always take a member and then zoom out and then make it look like, and in this case we did it with this truss. We treated that truss as a whole beam, and then we just simply looked at the different forces acting on it. So you had L over 2, you had L, L, L over 2, and then we knew that we had reaction forces. So we had AY and then FY. So this example here is the same as that there. So sometimes when just trying to quickly work something out, um, and of course be careful when doing it, you can go ahead and make quick approximations like this one here. And this was because we knew we didn't have to take a moment, so geometry was not too critical. And again, it depends on a case-by-case basis. So look at the truss, look for symmetry, note any symmetry, mark your reaction forces, gauge whether or not you need to solve for them. If you do, you can do it quite quickly. And if you ever have to figure out like how things are distributed, do the bigger picture. It's a beam trick, and that helps out. And then when taking your cut, always just look at where line of actions intersect, because these points are very helpful. This is a helpful point. If I was solving for CD, then this would have been a helpful point, right? So it's good to just see what that looks like, and find ways for you to like work more swiftly and efficiently. All right. So I do hope this example helped. And moving forward, we are now going to look at centroids, internal stresses, and like load distribution.